detailedly, try to understand detailedly, saying that what is the master node, what is the roles and responsibility of the master node, and what is the slave node, what is the roles and responsibility of the slave node. So we need to understand their roles and responsibilities. Then we will see the rest of the things, okay, one after one. So let's see, let me draw a little the diagram here. Let's say it's your name node. It is a name node, and you have a bunch of data nodes. Let's assume that you have a bunch of data nodes. Okay, so as we discussed yesterday, these are the data nodes who store who store the data. One second, guys. Who stores the data? Those machines are called data node. Let's say it's 1, 2, and 3, and you have something called client here. Okay, we'll be talking to this guy, right? So now try to understand roles and responsibilities of each and every component in this, okay, in this HDFS architecture. In this HDFS architecture. Someone is connecting over phone. Please keep yourself in mute, guys. Guys, if you are not mute yourself, I have to disconnect you from the meeting. If you are not talking, please keep yourself mute. It will disturb others who is spending their valuable time for this session. Please try to understand. I also know that you guys also know you guys also attending the session by spending a valuable time, but please mute. Okay, so this is our HDFS high level architecture. In the HDFS we have two different kind of nodes, different kind of machines, which are called name node and data node. So let's try to understand each and each and every component's roles and responsibilities. Okay, let's have a discussion about first a name node. Try to understand what is a name node. What is a name node? Okay, name node is a master node. Name node is a master node. The very first point is it is a master node. Who who maintains or who give instructions to slave nodes? Who give the instructions to slave node to perform something? Okay, and who manages the cluster? I can say who manages the cluster. So who maintains the namespace information? Who maintains the namespace information? Namespace information. So what is the namespace information? Namespace information is nothing but where you are storing the file. Namespace is nothing but where you are storing the file, right? So the namespace is a tree structure. Let's assume that in the HDFS I'm loading a data in the directory called HDFS slash data slash Amazon .txt. Let's assume that this is my file. So now this is your HDFS path. This is not your local path. This is your HDFS path. Okay. So this information has to maintain by your name node. Your name node will maintain this information in the form of tree structure. In the form of tree structure. What is a tree structure? What is the tree structure? This is my root. This is my root. Under that I have something called HDFS. Sorry, let me keep it in the same spelling. HDFS. I may have something else. I may have something else. This is my root. Okay. And under HDFS, you have something called data. You have something called data. Under data, you have something called Amazon.txt. So now your name node is maintaining namespace information about the Amazon data because you have loaded the Amazon data into data nodes. That information is maintaining by your name node. How it is loading, how it is writing the data into cluster, we already seen yesterday. Okay, so this is a continuation class for yesterday. That's why I'm skipping that. I'm not explaining you how it is writing into HDFS, how it is writing into HDFS, right? This is called tree structure. This is called namespace information. This namespace information is maintaining by your master node.
Ravi,
Yeah, Dheeraj.
Ravi, sorry to interrupt. When you say namespace information,
Hmm.
does it mean metadata or both are different?
The way the metadata means wherever the metadata contains our this data information, this namespace information. It is a very big object. Okay, it maintains the namespace information in the form of inodes. I'll explain what is inode. Okay, so I'll explain now only what is inode. So the namespace information means where the file is loaded in the HDFS location, where the file is loaded, what is the block size, what is the replication, what is the replication, what is the permissions. All this information will be maintained by your name node. When it has been created, when it has been modified, all this information will be maintained. And also where and all the data is loaded, that's called file to block mapping. Yesterday we have discussed something called file to block mapping. File to block mapping means the Amazon file, let's assume that my file is 100 MB. My file is 100 MB. This is my file, file 1 it is. Okay, or Amazon file, let's take same name. This is my file name. So now this my file is 100 MB. What is my block size? 64 MB. Correct? So if it is 64 MB block, it is 64 MB block, two blocks will come. One is the block 1 who occupies the 64 MB size, and the other one is block 2 who occupies 36 MB. 36 MB. So block 2. Correct? So block 2. So now these two blocks are belong to Amazon. How it will be represented? Amazon.txt has block 1. Block 1 means it's information. Okay, where it is loaded. I'll show you that. If I show that metadata file, you'll easily understand now. But for time being, you just assume that it is looks like this. Block 2. And this block 1 is might be stored at some place, no? So the block 1 is stored someplace, no? Here, here, 3 copies, right? And block 2 might be stored some other place, right? 3 copies, correct? So the block 1 is where is stored machine 1, machine 2, machine 3. Block 2, machine 2, machine 3, machine 4, whatever the order. Okay, all this information will be with your name node. Clear, Dheeraj? Is your doubt is clear?
Not really. Actually, I still couldn't understand. Like this information, you're calling as namespace or again
Okay,
metadata?
okay, so this information is metadata. Okay, this information is metadata.
Okay.
Okay, and this information is the namespace. Your name node maintain the namespace as well as a metadata.
Sorry, which information is namespace? The above one,
The path,
HDFS data
the
Amazon
path,
TXT.
the path.
Okay, all right.
The
Okay,
path
yeah,
is the your
understood.
namespace information. The rest of the data block block size, replication, permissions, who created, when created, what is the block, what is the size of the block, where the block is there. All this information is called metadata information. Is that clear?
Okay, all right. Yeah, yeah. Thank you.
Okay. So Your name node is a master node and it maintains the namespace information and metadata. The, the third point is it maintains metadata information. Metadata information in the form of two files. In the form of two files. The first one is edit log file. Some people will call journal file, some people call log file, some people call edits, some people call log, you can say or condition, or some people call log, some people call edits, or some people call journal. Okay, and second file is fs image. Fs image. Some people call image file, some people call image file. Okay, so what is edit log, what is fs image? For time being, you just understand it is a metadata information. I will show you very detailedly what edit log contains, what fs image contains. Don't get confused now only, don't get jump into those things. Okay, so it will maintain the metadata information in the form of two files. These two files will be in your name node local disk. These two files will be in a name node local disk. Where these two files will be there? In the name node local disk. These files will not be in a HDFS. These files will not be in a HDFS. Any doubts till here?
Yeah, Ravi, what is inode?
Very good. So inode we'll call as inode object. Okay, in the Linux, whatever the file you are loading, whatever the data you're storing, it will call as inode. The path is called inode. The inode is not a physical machine. It's a logical name of where you have loaded. The inode is an object which contains your where the what I can say where the file is. What is the let me put in this way, in this case, like permissions, who has modified, when it has been accessed, what is the disk space is allocated for that, right? All this information maintained by your inode. Maintain in the sense inode is the term is called inode.
But that was metadata. Yes, I mean you told just 2 minutes back.
The metadata is a very big term for it. Inside your metadata, let's say I'm taking metadata file. Inside the metadata, you will be having inode information. Information is nothing but where the file is there, whether it's a directory or not. Okay, I know that people are getting confused. Let me show you that file. If I show the metadata file, uh,
Like log.
sorry Arjun,
Is it something like log only, right? In that case?
no, it is not log.
Okay.
It is not log. Don't get confused. I'll just show you that. Don't worry.
Okay, Ravi.
I'll let it open. It's taking some time, I think. It is loading.
Ravi, by the time it is loading, I have one question.
Yeah, go ahead.
Why that metadata is stored on local disk, not on HDFS?
Very good
Is
question.
there any specific?
Yeah. So see, the metadata information is not required, but the metadata information is free. See, when it comes to HDFS is a different layer on top of your data nodes, right? The HDFS is a path or a layer which is the on top of your HDFS local file system. So whatever the file you are loading into a name node, that will be frequently referring by your name node. So if it is there in HDFS, again it has to bring to a name node. From the name node, it has to bring to name node RAM. Because the metadata information is there with the name node, because that is a single point of contact. Your name node is a single point of contact. Whenever I was asking for some specific file, I should be able to connect to before getting into HDFS. I need to get the information which HDFS it is. Am I answered your question?
Yes, Ravi, I understood a bit about this.
But still you have a doubt, it seems. I'll show you that.
I, I'll keep my doubt with myself. Let's see if it gets clear as
Sure.
session progresses.
Sure. So we cannot see these metadata information files. We cannot read. It's not in human readable format, but some tools to we can convert them into human readable files. The tools also provided by Hadoop 2. The tool is nothing but a Hadoop command. Okay, so I have used those commands already, and I have generated the what you call that metadata files. I'll be showing that metadata files now. FS image. No, so it's not in human readable format. You cannot get this. Let me open another file, which is FS image. I have you can generate whatever the format you want. The FS image file you can generate in a different formats. Okay, this is FS image format. Okay, so if you look at here, I have generated my FS image, my metadata file in the form of XML file. So metadata file or FS image file, whatever you call. Right, that file I have generated in the form of XML file. If you look at here, this is FS image tag is started under your name section, and I was talking about name inode section. In the inode section, this is inode, and you can see here what type of inode it is. It's a directory. Okay, I have created directory, and what is the permissions for the directory? Okay, I think it is if I open this file in browser, that makes you very much clear. One second, instead of this text file, let me open the browser. If you open with the browser, it makes you a little clear. Let me open it. Yep. So are you able to see now? This is a very big FS image file because I have loaded so much of amount of the data. So the whole amount of the data has to be represented in the metadata form, right? So that's why it's a very big XML file. So if you look at here, so if you look at here, let me show you for one specific file which I have loaded for let me which I remember bigger there is some bigger file. Yeah, so if I take this bigger file, if you see the inode for this bigger file, inode, someone asked me what is inode. See this inode object. Okay, you can call this inode object. See this parent inode is this parent inode is a directory. I have something called Vira. In that Vira I have something called file. The file is bigger file.txt. And what is the replication factor? 1, because it's by default 3, but I have changed to 1. Okay, so the time, the alternate modified time, or the created time, I really don't know what is m time and a time. We really don't need it to know also, but to show you, like to show some proof that it is storing the metadata information in the name node, I have created in the form of no this way, like inodes, I have generated this. So if you ask me what is this tag and what is this tag, really I don't know. I know one of the time is generator time. Maybe other one is when you alter
And
yeah.
Ravi, this directory Vira and inside that file bigger file.txt,
Hmm.
this is the path of HDFS, right?
Yes, that is a path of HDFS.
Okay, all right. Yeah, thank you.
Okay, so you just go here. If you see, as I said, it's maintained the inode form, right? As I said, it's an inode form. In this inode, this is the directory. In that, I have something called file. Type it. It is type ID of it. Okay, this is inode ID. It is inode type. It is the inode name. Inode in the sense the object I'm talking about here. And this is my bigger file, and this is my replication factor. Someone asked me what is replication factor. Sorry guys, I mean, you missed the last class. Because of that, no, you are not getting what is replication factor. Replication factor tells you that how many copies you have to maintain. The very simple, how many duplicate copies you want. and this is the preferred block size. Preferred block size. Okay, the preferred block size, if we convert this in it's in bytes. If you convert into MB, you'll come to know what is your exact block size. It is 32 MB is my block size. 32 MB is my block size. So you can convert it. If anyone interested, they can take this number. This is in bytes. You can convert into KB and you can convert into MB to understand my block size 32 MB. Okay, let me show you that as well. Okay, by the time the Hadoop starts, and look at here, this bigger file has been divided into multiple blocks. This bigger file has been divided into multiple blocks. Is your inode contains the permission as well, as I said, who is the user, which group is belong to, what are the permission has, all the permissions are there here. You can see in this tag. And the blocks, how many blocks are there, the specific file. That specific file, how many blocks are there. So we have seen yesterday, I have explained yesterday. So when you load the file, if it is a file is bigger than your block size, it will divide into multiple blocks, right? So these are the blocks. Look at here, there is something called blocks. Inside that you have something called block, and this is the ID of the block. Chandra, where is the block node here? Name node is the master node. Where is the block node? Where you see the block node? There is no block node. Okay, so and the blocks are the piece of data. What is a block? A block is a piece of data which will store in a single machine or single machine. I can say it's not the block will not store, the same block will not store multiple, one block will not go into multiple machines. One block will store in single machine. We'll talk more about it.
And Ravi, if you go ahead and modify one, I mean delete a file and add a new file to HDFS, this XML file will also be changed, right? I mean new blocks will be entered or few
So
blocks will be deleted, right?
could you please repeat your question?
So if you put more file from your local to HDFS, so this file will also be changed because this is metadata file, right?
This
So
file will not
metadata
be
file
changed.
will also be changed.
This
So
file,
this file,
sorry to stop you. This file will not change. This file will generate when you load the data. This file will be generated when you load the data with respect to what are the properties you are loading. If you see yesterday, we have loaded the data, right? So for this bigger file,
yeah,
my configuration is replication is 1 and my block size is this. Okay, where is that? My preferred block size is this.
yeah,
This is my configuration for that specific file. Okay, if you change the configuration, this file will not change for the old data. It will change for the new data which is going to your upload, which is going to load. The old data remains
yes,
same.
that's what I am saying.
Yeah.
So yeah. So if you put a new file like named bigger file 1.txt, so this file will be modified and few more entries will be added.
Modified in the sense there will be new entry will be added for this. This existing will not be modified.
Yes,
You can say that new entry will be there in this file.
yes. I am
Okay.
talking about this whole XML file. This XML file will be modified.
XML file will not be modified. It will be added the new entry in it.
Okay.
Let me show you that. This is
Yeah.
the bigger file I'm talking about, right? So you have some. You are
Yeah.
telling that there is something called bigger file 1. I should have this. Bigger file 1 is not
Yeah.
there. I should have this. Yeah. So I have something called bigger file 2. Is that Excel file is modified?
Yeah.
No. There's a new entry is there. New inode entry is there, right? The new.
Yes.
So the new
That's
entry,
correct. Yeah.
will be added. The existing will not be changed.
Yes.
These are the properties, guys. These are the properties which you have loaded the data into HDFS. These are the addresses. These are the references for that. Let's say the block ID is reference for that. Okay, the block ID is reference of the which data node it is. Okay, and
Yeah.
as I said before, it will be having the preferred block size is this. So if you change the block size for this by using some command, but you cannot change the block size, you can change the replication only. So for your information, so if you change the replication factor, this will be updated. This will be updated when you change for specific to this file. Okay, the replication factor will be updated. The block size you cannot update. You cannot change the block size. If you change the block size for this specific file, first of all, you cannot load the same file. The same file you cannot load in the same location. It will tell you that the file is already exist in the same location. I cannot write in that. Okay, so on this here you'll find the block information, block 1, block 2, and so on. You can find the block information here. I have I think close to 9 blocks, or 9 blocks are there, I think. Yes, nine blocks are there. Okay, you can see here what is the block and what is the generated timestamp, what is the block ID, what is the generated blocks time, and the number of bytes. Okay, all this information will be with the your metadata. So whether the permission information is metadata, or it comes under the namespace information. Okay, guys, the namespace information, the metadata information, both comes under the same file, which is called image file. Your image file will contain the namespace information as well as the metadata information. You are able to see here, right? So we have a bigger file. The bigger file is coming under Vira. So /Vira/biggerfile.txt. It means your metadata information contains your namespace information as well. Where this file is there, this file will be there in your name node. So do you want to see that where the file will be there? So the file will be there in the name node. In the Hadoop setup, you will be having a two different directories will be created. One is the HDFS under the HDFS directory. One is the data node, other one is the name node directory. Whatever the data you are putting, the data will go under the data node directory. Whatever the data you are loading, that data will go into data node directory. Who is loading the data into this? The client is loading. Actually, there is something called HDFS client. He will loading the data into this, and name node will contain the only namespace information. What is the namespace information? As I said, two files, right? One is edit file and fs image file. Those files will be here under the name node. You will be having those two files. So it's actually loading. So it's taking so much of time because I have so much of data here. Look at here. Look at here. These are all edits. These are all edits. Okay. And look at here. This is your fs image. This is your fs image. This is your fs image file. Okay, your image file. Okay, so this image file contains the all your metadata information. This edit log contains the transactional information. I don't want to take you into that direction. Now I'll tell you what is the transactional information. So the transaction information is like when you create a directory, when you created a file, so that information will be available in the your edit log file. So we'll see more in detail later. Is this clear, guys? Is this clear about your metadata information?
Ravi, we could see that there were more than one FS image, but there should be. I mean, if you put a file in HDFS, so only one FS image, and that will be modified.
Okay, so this is based on the transaction IDs. Okay, so to understand that, we need to go further. We need to understand the backup nodes, what you call checkpoint node, secondary name node. We need to understand them. So once you understand that, you'll easily understand why multiple FS image files are there. Okay, so it's a little early to understand that why multiple FS image, why multiple edits.
Okay, all right. Okay.
Any other doubt, guys? Guys, someone is talking on the phone.
Ravi.
Please keep yourself on mute.
Hello, Ravi.
Yeah.
Actually, where can we get this FSMS file in the folder? Which folder?
Okay. So if you have a Hadoop setup, in the Hadoop setup, you have to specify a directory for your HDFS and NameNode directories. Okay, you have to
actually I set up the Cloudera VM.
Okay.
So
okay, yeah. In the Cloudera VM, if you want to see that, you have to go to the HDFS site.xml. There is something called configuration file. So in the configuration file, you have to go and look at the path. The configuration is, let me show you the configuration.
I think it's in ATC.
Yes. Yep. See this configuration, your name node directory and your data node directory. You have to look at this. Okay, so don't get diverted, guys. Let's move no, move back to the original topic. So what we were discussing, about the roles and responsibility of the name node, right? Okay, so let's go back to that. Yeah, so the first role is a master, and he maintains the namespace and metadata information, and the metadata information will be maintained in the form of edits and fsmh. So what is edits, what is fsmh, we will see in detail later point of time. So at this point of time, not to worry about much, don't worry about more, no, as of now. Okay, I just want to remove this. Okay, let's take a new one. Okay, now the first one is a master. It's a master, and it's maintain the namespace information, and it also maintains the and also it maintains the metadata information in the form of edit log and fsmh, right? That's what we have discussed. That's what we have seen. Then what is the other role? So other role is, so as soon as the client sends a request to him, for writing a data, what happened? As soon as the client sends the request to a name node, okay, first he has some responsibilities. Like first he has to check whether the data is already exist or not. Guys, someone is still, I'm getting some lot of disturbance. Guys, someone, could you please keep yourself mute? I'm not able to find out who is that. Record it. So when a client sends the request to a name node to write a data in it, what he will do, first he will check whether the data is already exist or not. Okay, if the data is already exist, it will send the request back to the client saying that the data is already exist, I cannot write. Right, so this kind of the pre-checks will be done by your name node. So the next node is a data node. The next one is a data node. What is the data node? Data node is the slave node. Data node is the slave node who actually stores the data in it, in their machines in the form of blocks, right? So these are the slave machines. Where your client will connect to those machines, and they will start sending the transfer the data into data nodes. And these are the machines will be having something called job tracker, who will take care of the processing part. Data nodes are the responsible for storing the data in it. data nodes are the responsible for storing the data in it. So not only that, the data nodes are like when as we discussed, the block size is 64 MB or 120 MB, right? So let's assume that my block size is 120 MB. Okay, I'm loading the data which is 130 MB. How many blocks will be get created as we discussed? How many blocks will be get created?
Two blocks will create.
So one is 120 MB, other one is
And second one,
2 MB. So now it is 120 MB, right? So will it occupy the rest of the 126 MB? Will it occupy the rest of the 126 MB? No, it will not.
no.
It will not occupy the rest of the 126 MB. It will occupy only 2 MB space. So for in this file, for this block, it is the block size is 128 MB. For this block, the size is 2 MB only. So most of the guys and some of the blocks, when you read here and there, so you'll get confused saying that. So it will be rest of the 126 MB will be wasted. Rest of the 126 MB will be wasted. You cannot make use of that data for any other purpose. No, that's really wrong. So there is a proof for it, right? So you can see here in the metadata itself, right? So we have seen the metadata itself. If you see in the metadata itself, the bigger block, if you go to the last block, this is my last block. If you see, this is occupied 32 MB, it is closely occupied 17 MB only, right? This is occupied 32 MB and it is closely 17 MB, right? It means, so even though your block size is fixed as a 64 MB or whatever it is, whatever the data is loading into the memory, that much data only will be treated as a block. So the rest of the space will be anyway as it is. I mean, it's a free for store other data. That space can be utilized for other purpose. That space can be utilized for if other purpose. So other data or other blocks can be loaded into that. Clear, guys, about data node and name node? Any other doubts?
Veera, one thing, like you have two files,
Okay.
one with 128 130 MB and the other with 512 MB.
Okay.
And so here as per the architecture,
File one
there should be
is
at least two.
file.
Yeah, file one is 128
Okay.
or 130 MB,
Okay.
and the other file 2 is 512 MB.
Okay.
So in this case, we more than two blocks.
This file will, it is a file wise, right? It is not like all the blocks clubbed together, right? It is a file wise. So as you see here, it is a file wise, or it is a all clubbed and it is no occupying the space. It is not that case, right? It's a file wise. If it is store file wise only, you can retrieve the file wise, otherwise you will get the wrong data, right? So if you see here, file
Yeah,
one.
so what
I'm coming to that.
my question here. Yeah.
So
Please.
your file one has a two blocks. Okay, your file one has a two blocks. One is 128 MB block, other one is 2 MB block. Okay, so coming to file 2 has a two blocks. I mean, four blocks it will come, right? 128 128 4, right? So it has a four blocks. So all the blocks are 128 MB 128 MB. Yeah, tell me your doubt now.
So when the third file 2 MB is being occupied from the file 2, or is it being used by the file 3, or how is it the coordination between the storing the data and accessing the data happens within the blocks?
Okay, so very good question. So it is,
we don't know like which file is using the which block.
very good question. I understand what you're trying to ask. So when it comes to the distributed environment, so the whole space will be treated as a single hard disk, correct? The whole space treated as a single hard disk. Even though if you have multiple machines here, Even though if you have multiple machines here, the whole space will be treated as a single. I mean, for the client, it looks like a single hard disk. That's the distributed file system. That's the DFS or NFS, whatever you call. Right now here, see, there are multiple scenarios. What we need to discuss of multiple scenarios. First one, the file one may stored in machine one and machine two. Okay. Let's assume that I have 4 more machines here. Now the file 2 might be stored on these machines. Possible? It's possible, right?
Yeah, possible.
So when it comes to the distributed environment, the whole space will be treated as a single space. The whole, whatever the disk space is given by this machine, whatever the disk space is occupied, given by this and given by this, all these machines, it will be treated as a single space. So the first two machines are occupied 2 blocks. So the second file can occupy from the here itself. Can occupy from here itself. Okay.
Okay.
Didn't I mean I understood? No, you didn't get the point. Let's assume that my whole the size of this is let's take 1 GB. Okay, my whole space is 1 GB. This whole space, my whole cluster space is 1 GB. In this 1 GB space, you are trying to keep file 1 and file 2. Okay, the file 1 is, let's assume that the file 1 is occupied this space, and the file 1, block 1, which is FB1. Let's say that's FB1. This is F1B1. It is F1B2. Okay. Now file 2. So now it is 130 MB is completed from 1 GB. So rest of the space will be how much? It will come close to 900, right? Close to 880, 890. Let's say 896 or something. It will come. Okay. Now when it comes to 980 or 990, okay, this space you can load any data. So I mean, how this rest of the space is free for you, right? You can load any data in this. It can be in the here, or it can be here, it can be here. So I didn't see any problem here.
But Ravi, here I have a doubt. Like cluster is made of some commodity hardware. If say you have put like X number of files in one system, and only like say I mean 10 MB remaining in that particular computer, but you are putting a file of say 100 MB.
Okay.
So, but the block will be of 100 MB only. So that 10 MB is wasted, or that also we can utilize?
So very good question. That's the reason when you are making the cluster, right, we will be having something called threshold. Okay, each mission, when you are making the cluster, it will be treated as the same. It will be treated as a single space on. As I said, it will be treated as single space from all the missions, right? Now each mission.
Yeah.
So how much data it has to fill? How much data it has to fill? We already will be setting the threshold for it. Okay, based on the threshold, it will be I mean it is more into admin work. So what he will do,
okay,
while setting up the cluster itself, he will set up the same thing, like my threshold is 60%. So it will make sure that so all the missions are not get full. I mean any of the one mission will not get full.
okay,
and they'll be keep running this, they'll be checking the health check of it, and they'll be running this rebalancer.
Okay.
So to balance the data, suppose if any of them, this mission is about to reach 60%. So what they will do, when they execute this rebalance command, the data will be adjusted into into the cluster.
Okay. All right.
Yeah.
Okay. Thank
So
you.
yeah, coming to the previous question, someone asked me file 1, file 2, right? In this case, so the data, the space is never wasted. Okay. So as I said before, you can hold space if you take it as 1 GB. So whether it is storing in a machine 1 or this is storing in a machine 2, the rest of the other two, I really didn't see what is the problem you're seeing there.
Okay, maybe I think like if the file is being stored in case of sequence order, that is completely wrong, right?
No,
File cannot be stored in a sequence.
No.
Yeah. Yeah, right. So I see a problem here. Like when there are multiple blocks, when the file size is more than 128 MB, so how the storage of the file happens to be stored in different blocks, and how it can be accessed, during the retrieving purpose. Like how does it identify like this particular block belongs to this particular file?
So that information is there at the name node, right?
So
I have
that,
the
and there's only one single name node, right? There are not multiple name nodes.
so it's if your cluster is a very big cluster, you can go with the multiple name nodes. It doesn't mean that you always have only one name node.
Okay, okay.
Okay, you're keeping multiple name nodes in the cluster. It's called federation. So that's a completely different. Having a multiple name node is possible. That is called Hadoop federation. We will talk about that. So there is some there you need to understand block pool ID. You need to understand cluster ID. So there are so many things are there. So we will talk about that later, little later.
Ravi, one more question. Like you mentioned, if client is copying a file, NameNode first checks whether that file is already present. If it is present, then it will tell the client that you cannot copy it.
Correct.
Now, like with multiple clients, like client one is copying, have copied a file x.txt, which now client two is copying a file x.txt, but that x.txt is different from previous x.txt.
So
But
different means the path
coincidentally,
is
the
same.
name is same.
The path and
Yeah,
name
they
is
want to
same.
copy. Yeah, they want to copy in the same part, but name is same. But like the content is different. Still,
Yeah.
you will not be allowed to copy.
No, you will not be allowed to copy. This is called each client will take a lease. Okay, there is something called lease. So what they will do when they went to the name node to write the data into HDFS, they will take the lease
Yeah.
to that file to write. Okay, they will take the lease to write the file. If any other client comes to trying to access the same file or try to do the same with the same name, the lease will not be available.
So client knows beforehand that this particular name already exists.
Client will not be knowing that. How client will be knowing that? The name node will be knowing it.
Yeah, so I mean, client has to do hit and trial. Like, okay, uh, put x.txt. Now NameNode will tell that x.txt already
Yes,
exists. So
yes,
he will
yes,
try with the new name.
correct.
Okay.
Ravi, Veera,
Yeah.
how long does it take to add the file? Suppose say the 1 GB file
Mm-hmm.
on a HDFC. How long does it take?
It's based on the I mean, so I never observe how much time it will take. Um, so based on the what you say, the processor you're using for the client machine, the processor you're using in your Hadoop cluster.
Like usually in the real-time practices, right? Like what kind of files? Like the files are with the smaller size or with the GB kind of size, or what is the file size like
So
in kind of real-time scenario?
in the real time, if it is see, if it is not a historical data, if it is not a historical data, it will be very less. If it is a historical data, let's say of last 1 year data, last 2 years data, the data will be huge. If it is, I have seen some
Okay,
data where is 4 TB for last one and a half month.
okay. So in case if it is a 4 TB, then that file is being divided into 64 MB,
Yes.
something like that, or what?
No, your 4 TB data is not a single file, right? Are you saying this a 4 TB file? 4 TB is a single file or multiple files?
Yeah, might be a scenario, right? There might be a scenario of at least 1 GB file.
A 1 GB file, it will be divided into multiple blocks.
Okay,
Even
okay.
it's really no matter, right? It's one GB file or 1 TB file. So the matter is the block size. When the data is going beyond the block, it will divide into two blocks.
Okay.
The size of the file or the size
Ravi,
of the
thanks,
data.
thanks, Veera. Thanks.
Yeah.
Oh, the size of the file, the content of the file is not prioritized here. The only thing what actually matters is the how it is stored
Yeah. See,
with respect to the.
yes. Your file size is, let's assume that your file size is 128 MB only. Then it will fit into only 1 MB or one block. It will fit into only one block.
Okay, okay, okay.
Yeah.
And one thing, like how do a user identify HDFS and LFS, like local file system and
User in the sense,
HDFS?
user and
How?
means the developer or the client, or who
See,
user?
you're a developer, you're well aware of it, and a tester is also well aware of it, because at the customer location, operator who doesn't know how to transfer the files from the LFS to HDFS, how can he does that?
So
How
client,
can he transfer files from?
the person who is not aware of Hadoop, he will not come. He will not going to load the data, right? The data loading and everything will be automated, right? So it will be automated. So from where the data is, sorry.
Hadoop operator. There might be a operator, right, like to loading the files and all in the customer premises,
No,
who might not be knowing much technology about HDFS.
no, there won't be any manual load in the real time, or there won't be any manual load in the production. If it is really required a manual load, so
Okay,
what
so everything is
what we have to do, we have to give a document to him. So you copy, no, copy paste the, change the paths and all. We need to do that.
okay. Okay, got
So
it.
this has
Thanks.
there is something called, there'll be something called jobs. Okay, we will schedule all these jobs using your cron job, or using your Ruzi job, or using Ashkabana job. There are some tools to schedule your jobs. So what
Okay,
their responsibility, let's say if you're talking about layman who is a client, so what is his responsibility? He has to put into specific location, that's it, or specific machine.
okay, okay,
From his end, that machine can be his NFS machine, or a network file system machine, or any other normal file system. So picking from there, it is like our what we call uh, uh, our job to take care of it.
okay, okay.
Yeah,
And one last question. I don't want to disturb you more.
it's
The
okay, it's okay,
last,
go ahead.
like, the file, the content might be different. Like it might have an audio file, audio. It is a mix of everything, right?
Yes,
Like
you
audio,
can.
it might be a image file or an
Yes,
video file.
yep, you can load any type of file.
Yeah, we can load anything. We can have an integrated set of files being dumped onto the HDFS, or we can have an in case if it is everything is dumped, right? HDFS prefers to have audio sets of files to be stored in particular block, and text file in a certain particular block. Is there
See,
any kind of priorities for the blocks?
so any type of data, whatever the data you keep, it will be divided into blocks.
Mm-hmm. Mm-hmm.
Yep.
There might be a audio file, there might be a video file, there might be a log file,
Uh,
everything combined
yes.
within that 64 MB.
No, I mean combine within one
Okay.
file, one block. It will not combine two different files. Could you please repeat your question one
No,
more time?
yeah, I have a file with multiple data formats.
You have a file with multiple data formats. Okay.
Yeah. So when I'm storing that multiple data format file into a HDFS,
It's a single file or multiple?
so which is a
It is a single file.
it's a it's a single file.
Okay.
When I'm storing it on HDFS
Mm.
on a block
Mm.
with a size of 64 MB,
Mm.
so that block of 64 MB will again have a multiple data set format, or the data is being segregated and being stored on HDFS.
It
How it is done?
it is physically cut the data into pieces. It is physically cut the data into pieces. Hello. Hello, Raghu, right? Raghu. See here. So I'm just
Yeah. Yes.
I'm just drawing here. If you see here, this is my file. Okay. So you were telling that this
Mm.
file, this you were telling. Let's assume that this file has a text, this file has a table, this file has an image, this file has a what you call audio, video, everything is there in this file. Okay, and
Yeah.
this file size is 150 MB. Okay. Now when you're putting
Okay.
this file into
Okay.
HDFS, it will just break into two pieces. Whether in the first part it can be text, it can be audio, it can be video. In the second part it can be only video, it can be text, whatever it is. It will just physically cut into
Okay.
pieces.
Okay. Mhm.
The first part is the block one. The block
Okay.
from the 0th KB till 128 MB, whatever
Okay.
comes under this range, it will blindly go ahead and take it. But the
Ravi,
processing,
for text file you can, I mean, cut into the blocks, but I mean, how can you cut the image if that is JPG file?
Whatever the file,
So the data might be corrupted, right?
okay. So very simple question here for you guys. So you are loading your videos into your drive. I mean your file systems, your pen drive or your on a hard disk. How it is loading internally? It's loading the small blocks only. It is dividing the data into small blocks. The same here as well.
Yes.
Yeah. Okay. Okay.
Okay. Even for the image?
Even for image, any type of data,
Okay.
you load any type of data. Whatever the data you're putting into HDFS, it will just break into pieces based on the block.
Okay.
Yeah, it is same.
I'm
Same
just
way.
wondering.
This thing, how it is working. The same way it stores the data.
Could you please repeat, Tulsi?
Yeah, yeah. I'm saying how it is working in currently, like
Local file
pen
system.
drive or
Yep, local
yeah,
file
local
system.
hard disk. It only depends on the size of the block. So
Yes,
here in HDFS we are mentioning the block size is high, is more compared to normal system. That is the only difference.
yeah. Any other questions, guys?
Ravi, I have a last one question.
Yeah, Amit.
For the example that Raghu was asking, file 1 is having, let's take size of 130 MB.
Okay,
And so you divided, it will be divided into two blocks, 128 MB and 2 MB.
okay.
So there is 128 MB is available, so it creates one block, but there is only 2 MB. So logically, it will create only one block and it will process as a block of 2 MB.
Correct.
Like we are talking about 128 MB, it's not like the case that it will wait for the remaining 126 MB. It will create a logical only 2 MB block and it will be processed as a 2 MB block. So
It's actually, it's not a
now
logical, it is a physical only, Amit.
physical also.
Yes, it's a
Okay.
physical only. It is a physical block only. Logical block will come something in the processing area, which is called MapReduce. So here, whatever you're loading into HDFS is completely physical data.
Oh, so point is, it's not necessary that always block size will be 128 MB. It may be less than 128 MB as well,
Yes,
depending on the available data we need to load.
yes. It depends on your file size.
Yep. Okay. Okay. Thanks, Ravi.
Okay, so here I have come a few set of questions. Let me go through those questions, guys. What is the tool to convert FS image? Guys, the Hadoop 2 is given something called offline image viewer, offline OIV and OEV, offline image viewer, offline edit viewer. So I'll show you that command anyway. It's a HDFS command. It's not an external tool. It is a HDFS command. It is a command, or it is a tool from HDFS itself. And DataNode and NameNode will be in the same system. Okay, Manoj, as I explained yesterday, it is a pseudo mode. If it is a single machine, you are setting up your Hadoop cluster, yes, both will in the same machine. If it is a real-time cluster, if it is a development real-time cluster, you will be having a NameNode is a separate machine and DataNode is a separate machine. And
Vida, ideally, what will be the configuration of NameNode and DataNode? Like, what is the configuration of the hardware?
It really depends on your data you are going to handle, Raghu, right? Yeah, Raghu. So most of the time we'll go with the good hardware for the name node because it's a single point of failure. So for the data node, we'll go with the commodity hardware. So here I have seen machines which is a 64 GB RAM and 1 TB hard disk for the data nodes. And for the name node, I have seen highest high end is 1 TB RAM. 1 TB RAM I have seen, 512 GB RAM I have seen, and even 128 GB RAM also I have seen in the name node.
Okay. Okay. Yeah. Thanks.
Yeah, two replication Dheeraj is telling two replication factor. I didn't understand. Naga is telling one file 130 MB is loaded into HDFS. Same file modified 200 MB and the load once again to the HDFS. How would the data would be arranged in the blocks? A nice question, Naga. The question is what Naga is telling that the question is the file one is 130 MB now. Let's take an example. The file one is 130 MB. I have loaded into slash data. Okay, and the file one it is. Okay, now I have modified this 130 MB to 200 MB. Can we load this file into the same location? Can we load the file into the same location?
No,
We
it
cannot
cannot be
load
loaded.
because it says that the
Yes.
file is already exist. And if you change the path,
Yes.
if you change the path, it will treat as a new file only. So no question there. Yeah. So
Yes.
we can't modify the file in HDFS. Yes, Sandeep, we cannot modify the file in HDFS. You can append the data to HDFS. Once you load the data into HDFS, it is a read only, but you can append the data. In Hadoop 2 onwards, there is something called append to file. Okay. In Hadoop 2 onwards, you can append the data to existing data, but you cannot modify the existing data. There's silly reason, guys. Very simple. No one is interested. So the Hadoop we are using for the huge data, let's say terabytes of the data or GBs of the data. Who is interested to go and modify the specific number of line, 100th line of in the 1 TB data? No one is interested, right? So even it's a costly operation. So we need to find and we need to do all those things. So that's the main reason is that. So we don't want to allowed to modify the data in HDFS directly. But if you go through if you go through like Hive HBase, you can do that. Vishal is
So
asking,
delete.
delete can be possible. I'm talking about
Okay.
update. Through Hive and HBase, insert. I mean, you can insert the row level. You can delete the row level. You can update the row level. Update also possible through Hive, through HBase. But directly HDFS through direct HDFS commands, no, it's not possible. You can remove the file. You can load the file. So Vishal is asking me, Hadoop supports structure as well as unstructured files. Yes, both it will support. Yes, the Hadoop is mainly meant for that only. Anil is asking, Naga, you cannot load the same file again. Okay, he's already answered to him. Yes, okay. You mean two files will not store in a single block? Two files never go into single block, guys. For the file 1, the block will be different. The file 2, the block will be different. And yes, because the explained earlier, if you are trying to load the same file, it will be get error. Okay, and two files with the same name cannot be stored. Okay, so yeah, any doubts, guys? So that's it for today. I mean, I feel today whatever I thought to deliver the content, I